There should be sufficient cooling in electrical machines to avoid damage due to high temperature. The life of the insulation reduces drastically with temperature. An example of a squirrel cage induction motor is taken. Total loss is calculated measured by performing no load test. Knowing the total loss, required air discharge is calculated. Losses in the squirrel cage induction motor are stator copper loss, rotor copper loss, iron loss, friction and windage loss, and stay loss. Calculation of stator copper loss is done as follows. Input power equals to output power divided by efficiency, and input power is given by root 3 VI cos phi. Knowing current and resistance of stator winding, stator copper loss is given by 3I square R. Iron loss varies with flux density. Flux density varies with voltage, hence iron loss varies with voltage. Iron loss also depends on frequency. Since frequency in rotor is very less, hence rotor iron loss may be neglected. Fixed loss, e.g. iron loss plus mechanical loss, is obtained by performing no load test. Iron loss and mechanical loss are separated by plotting input power versus voltage. Friction loss is a loss in bearings, whereas windage loss is a power required to run a cooling fan. Windage loss is considered loss, as power to run a cooling fan is not available to mechanical output. All miscellaneous losses are considered as stay loss. These are not easily measurable. These are taken as 0.5% of input power. An example of a stay loss is skin effect. It cannot be calculated measured easily. Calculation of rotor copper loss. Power flow diagram is done. Rotor copper loss is given by slip into rotor power input. It can be seen that rotor copper loss is equals to S divided by 1 minus S into gross mechanical power. By adding all these losses, total loss is calculated. Air discharge is calculated by using heat equals to ms delta T and dividing both sides by time. When total power loss and permissible temperature rise, air discharge is calculated. Question is how much should be permissible temperature rise? It depends on various factors, easy class of insulation. Hot spots temperature is also considered. It also depends on ambient temperature. It also depends on the type of enclosure. In SPTP enclosure, permissible temperature rise is higher. However, this type of enclosure is not preferred, as dust may enter into the machine. Totally enclosed enclosure is preferred, but permissible temperature rise is less. Permissible temperature rise is reduced due to cooler drop in external circuit. Air discharge is kept much higher due to various other factors. There may be drop in voltage which increases stator current, thus increasing stator copper loss. Heat produced is more during starting. During starting, input power is not fully converted into mechanical power. The balance power is converted into heat. Various other topics related to cooling will be covered in the next video.